Last and final problem, number 10 of the 2-1 to 2-5 review. And again, calculators are allowed for this portion of the review and for the free response question that corresponds to this on the test. So if we read the problem, it says we're given two functions f and h such that f is a cubic polynomial and h is that cubic divided by x minus 1 as long as x doesn't equal 1, and then p when x does equal 1. Our first goal is to find all the zeros and then use them to factor f. Part B is we want to find the value of p so that the function will be continuous. And then we want to use that value of p to figure out whether or not h is an even or odd function. So for part A, we want to find all the zeros, and we have a calculator available to us. So there are a variety of ways that we can find this using our calculator, find the zeros. I'm going to show you just one of them. So the first thing I would like you to do is turn on your calculators. And let's go to the home screen. I'm going to enter that function f into the y editor. So I'm going to second and y editor, what's in there, and now we're going to enter the function. So function f is x cubed minus x squared minus 16x plus 16. So I'm going to assume you'll see that to enter that in. So now there a variety of ways, as I said, to find the zeros. The first way is we can graph it and look for the zeros. So I'll show the method first. If we look along the top here, we can see that we have an option zoom. So just like with our TI-84s, we can select that F2 option and do a zoom 6, which is standard window. When we do that, we can see our cubic function being graphed for us. And we can pretty much just look at the scaling to see that we're intersecting at -4 and at 1 and then again at 4. So we have our three zeros of -4, 1, and 4. We could verify that those are indeed the zeros by hitting F3 for trace and typing in -4 and verifying that yes, indeed, we got 0 out. We can type in 1, verify got a 0, and we can type in 4 and verify that we got a 0. Now the other way that we do it is to use our old algebra menu from the home screen. So if you select home and go back to that home screen, remember that we have stored that function in y1. So if you remember how we did factoring in class, here's F2 algebra key. You can select that and arrow down to factor, and then we can factor the function and we put it to y1. So if we type y1 of x and then tell it that we want to factor with respect to x and hit enter, we can see that +4, +1, and -4 are going to be zeros of the factored expression. So the reason that we want to do this factored version is because it's going to help us with part B. So let's return to the problem itself and write down part A. If we look at part A, we want to find all the zeros of the function. We did that on our calculators and we found that the zeros of f are x equals -4, x equals 1, and x equals +4. Now notice we've got the second piece of this, which is we need to use them to factor. So the factoring would give us f of x equals x minus each of those zeros. So we'd have an x plus 4, an x minus 1, and an x minus 4. This would get you your full points for part A. Part B says we want to find the value of p so that the function h is going to be continuous. So for continuity, we will write down the definition of continuity at the joint, which we can see is 1. So we would write h is continuous at x equals 1 if the limit as x approaches 1 on h of x is equal to h of 1. Now writing this one statement will earn you 2 points. And just to kind of backtrack a little, we can see that we would get 1 point from factoring and we get 2 points for finding the zeros. So this part is worth 3 points on your exam.
finding the value of p so that the function is continuous is going to be worth 4 points. And 2 of those points come just from writing the definition of continuity as it's applied to h at the x value of 1. So then the next 2 points of this section are going to come from figuring out what that p actually is. So if we look at our function for h as it is defined, we can see that h of 1, if I want to plug 1 into this function, we will output a p. So we're going to need p to equal whatever this limit ends up being. Because this limit is approaching a joint, we will need to examine what happens to the left and right of 1. Fortunately, in this particular problem, if I approach 1 from the right, I'm in the top branch, and if I approach 1 from the left, I am also in the top branch. If I plug 1 in, I can see that I'm dividing by 0 on the bottom, but if I plug 1 into the factored version of f, I also will end up with a 0 over 0 on the top. So this is evidence of a hole, and will probably generate a value for p that we can use to make the function continuous. So I'm going to use that one branch, which is f of x over x minus 1, and I'm going to write my f of x in the factored format so that I can fix the problem generated by plugging 1 into the denominator. When I do that, I'm left with the limit as x approaches 1 from both sides on the function x squared minus 16. If I plug 1 into that, I get a negative 15 for my p. So now I'm going to scroll this up, which might make it a little difficult to see the full problem. But part C is we now want to use that value of p to determine whether h is even or odd. So before I do that, I'm going to rewrite my h, because as long as x does not equal 1, the function's top branch, f of x over x minus 1, is going to be equivalent to an x squared minus 16, as long as x does not equal 1. And when x does equal 1, well, that's when we get the negative 15 out. So if I look now at determining whether or not we have an even or odd, let's remind ourselves that an even function occurs when plugging in an opposite generates the exact same output as when I plug in the positive. Whereas with an odd function, when I plug in the opposite, I will get the opposite of the original output. So to test whether h is an even or an odd function, we want to plug in the opposite of x and see what happens. When I do that, I will get here. When I simplify, I will get h of negative x turns out to be x squared minus 16 and negative 15, which is the exact same function as h of x. Because of that, we can conclude that h is an even function. So now if we go back to our rubric so that we can kind of see how these are, how the points are distributed. Back up here, remember we had 4 points. 2 of them came from the definition of continuity. 1 of them is going to come from computing this limit, and then the final one is going to come from identifying that p has to be negative 15. So when I look for the computing of the limit, I'm going to look to see, did you factor and reduce and then plug in 1 to get negative 15? And remember, if you drop your limit before you've computed your limit, I'm going to ding you for notation errors. So make sure that you keep this limit as x approaches 1 attached until you have plugged the 1 in. So that final thing, we'd get 1 point for computing the limit with the correct notation, and another point for setting p equal to that negative 15. The final part is worth 2 points to give us a total of 9, and this is the case for every free response that we ever do. We're always going to have 9 points available. So our final part, C, is we need to illustrate that h of negative x is the same as h of x, and then we have to conclude that h is an even function. So that is your free response. Good luck on doing well on your test.